In today's video, we'll be looking at Logstash and using it a little differently. We'll use Logstash as a server in order to import events and documents from external services. We'll walk through a few simple use cases on how you can get data into Logstash. So in this video, we'll look at Logstash to listen to TCP events over a network. Then we'll add HTTP as an interface to put documents into Elasticsearch through Logstash. And at the end, I'll show you how you can remotely collect data from a Beats program. Alright, Logstash started as the local agent you would install on a machine, on a server, something to monitor your infrastructure, to grab data from log files. This was at the endpoint or as far away from Elasticsearch as you can imagine. As time went on, and after the company Elastic bought or integrated Logstash into their main product pipeline, then it really became this full application to handle all the data from one source, many sources. It kind of became this big data processing engine instead of an endpoint collector of logs. So one of the capabilities that was really focused on was pulling in this external data. So not just local log files or local syslog on a Linux machine or Unix machine, but now Logstash could connect to external services, it could receive data, it could be pushed data to, it could pull data from an external system. So when you use Logstash now, typically it will kind of be the center of your data processing pipeline as opposed to the endpoint. Imagine you have a Kafka system that's processing all of your events across many topics from different applications, or you have a ZeroMQ common infrastructure within your enterprise, maybe RabbitMQ, an AMQP server, or any other ways you want to get data into Logstash. Think about monitoring your GitHub, and you have a GitHub account, and when a change happens at GitHub, Logstash can do something. It doesn't just have to put things into Elasticsearch. It can run other commands. It can make HTTP calls. In the GitHub example, you could even have Logstash kick off another service that could do a build of your software and do your testing. So there are so many ways you can get data into Logstash beyond just local log files. So I want to look at a couple examples. So we're going to run a demo right now, and I'm going to start and walk you through using a TCP input and an HTTP input. You'll see me using Telnet on my Linux server. Telnet these days does not come pre-installed sometimes, so I did a quick sudo yum install Telnet. The reason being, from a networking standpoint, Telnet's an open protocol. It's plain text and people can watch it. So typically you use SSH for remote commands, but for this demo, I want to show exactly as the packets go across a wire and what data Logstash will see. So I will log into my server. This is the same server we've been using. It has Elasticsearch and Kibana. And here I have a lot of configuration files. So let's first look at this TCP configuration. This is a Logstash config file like we've seen before. And you'll see the important input. It's a TCP input, which means it opens up a TCP server, a server socket on this Linux machine. In this case, it's port 12345, your TCP port of 12345, which means any client, any TCP client that makes a connection to that port can send in data. Once it sends in data, Logstash is going to treat each line like a document, the single message document we've been looking at before, and it's going to, in this case, it's going to dump out the Ruby debug statements that we like to see on the console, and it's going to look in Elasticsearch. We're not going to look into Elasticsearch in this video because I'm mostly interested in getting data into Logstash as opposed to the output of Elasticsearch. But let me show you what happens when we run this. So we'll run our sudo user share logstash bin logstash. And we'll tell it this TCP config file. So once we run this, we'll see that Logstash will start up. And once Logstash is started, we can create a TCP connection using Telnet. We'll be connecting to localhost on port 12345. And you can see when we get this output from Telnet, it has successfully made that connection. So we can type in anything we want. We can say, "Hi, Mom." And if you look at our server, our Logstash output on the top, we'll see we got the message we expected of "Hi, Mom" with a new line, return carriage. from the localhost port 34660. So it's the client TCP port of 34660, which we know connected to our server port of 12345. So we can continue to write messages. And you can see all of those messages come out of Logstash. So that means that Logstash was listening to that TCP port and processing each line as a message and doing what you configure it to do in your filters and your outputs. So the next thing I want to show you is how we can make an HTTP endpoint. So very similar. I'll even keep in the TCP port as the, just because it's there, and I haven't deleted it yet. And now I have an HTTP listener. So this listens to HTTP events on port 1181 of host 0.0.0.0, which means it's going to listen to all network interfaces on this server. So instead of just localhost, it'll listen to the public IP address or more if it has them. And again, my output is going to be the same, Ruby debug and Elasticsearch. So for all of these small demos of the different inputs, I'm not going to be doing any filtering or any output besides Ruby debug and Elasticsearch. So here, let's run this one as logstash http.conf. Now, once Logstash starts with that configuration, we can run curl to post a message. This HTTP server that's built into Logstash listens to HTTP post events. It looks at the payload of that HTTP post, whether it's URL encoded, whether it's a form field or a JSON structure, depending on your headers. Here, I'm just going to pass in a basic message. So I'm going to tell curl, which is my HTTP client, to do an HTTP post to localhost port 1181, and I want to pass in a message that says this is an HTTP post event. And if we watch our server at the top, you'll see we got some extra data here. So what we can tell is that we'll find our message. Where is my message? Here's my message. This says this is an HTTP post event, like I posted below. But here now we know the input is providing different data for us. So it's providing us the request path. These are HTTP header information that's going to come out of this HTTP request. It's going to look at these request method, the HTTP accept versions, my user agent, content type, etc. So here, let me show you some changes to that. Specifically, let's look at the request path and the request URI. So I'll make that go down a little bit. So in my HTTP client, I'm going to change my URL. I'm going to say another URL. So now up here, we can see our request path has that another URL. A request URI is another URL. A great use case for this, if you wanted to listen to a bunch of HTTP requests on a network or something like that, I could imagine setting up a reverse proxy that sends data to your Logstash or just an application. This is a great way to post data to your Logstash pipeline. If you have a simple application that the best way you can get data out of it is via an HTTP request. So far we've seen a bunch of string data. What I'm going to show you now is a little bit beyond that. So we'll still do HTTP. So if we look at this http2.conf, I'm going to throw in something new. I'm going to create an HTTP input that's going to listen on 1182, TCP port 1182, the same host of 0.0.0.0. And here, I'm going to tell it to use the codec of JSON. In this, it means it's going to take the message from that HTTP post body, try to deserialize it as a JSON structure into a standard dictionary, a standard map within Java or within Ruby or any language you're used to. So we'll take that JSON structure and unmarshal it. So let's run that real quick, and I'll show you what happens when we run it. Okay, our Logstash servers are running, and I'm going to show you the command before I actually execute it, partially because I never remember how to set the content headers. That's between you and me. So here I'll do a curl post. I'm going to add an HTTP header that says the content type which I'm sending in my HTTP post body is a JSON structure. So you can see the example above it. So I'll just type this as I'm doing it. I'm going to connect to HTTP protocol on localhost port 1182. The -D is the data or the JSON payload. I'm going to do a single tick because I know my JSON structure has double quotes in it. And let's set something up. I'll do first name is Chris, last name Fauerbach, website fowie.com, and I'll finish it off. I'm going to clear my screen with just that command. It just shows us the last page of it. And I'll execute it. Now look at the top here. Now I have this extra data. So instead of just a message, I have the variables or the values within that JSON dictionary. So you'll see I have my first name of Chris, last name of Fauerbach, and my website of fowie.com. Now these are added attributes to this object that's coming out of Logstash that in this case comes to our Ruby debug output as well as Elasticsearch. And now out of curiosity, again, I forget what happens. So here I'm going to pass a -v to show you what the client side sees from a curl command. Curl-v shows you the debug output. You can see it's trying to connect to the server, the port. It is making a client request of post to the root URL. User agent is curl, etc., as we would expect. Then it sent the data. And we can see we still got an HTTP 200 because that 200 did go to Logstash, and Logstash accepted the data. So it's later down the pipeline or down that debugging, decoding of that JSON that it got failed, and therefore this is an interesting find. I would not have expected this, but Logstash isn't telling us that there's a problem. Interesting. So we learn something new every day. What I'm going to show you here is how we can now use a Beats program to remotely send data. So here I have a metricbeat.conf for my Logstash, which means I'm going to listen to host 0 of port 5044. And for metricbeat, I have an original config file that has my outputs going to Elasticsearch. Remember when we had our metric beats coming to Elasticsearch? So we can find this section here that says output Elasticsearch in the host. In this case, I want to comment it out. So I don't send to Elasticsearch, but instead I send to a Logstash node by uncommenting out the output Logstash section. And now Beats will connect directly to Logstash. Now the cool thing about this, in my opinion, is that Beats is a protocol. It's not an application. So we've talked about metric beats, packet beats. I'm sure there were other beats we've mentioned so far. But they all use the same protocol when they're sending data across the wire. So it doesn't really matter which Beats config file we're using or which Beats application we're using. As long as we're using the Beats protocol, we can send data to Logstash without Logstash having to care. I don't have to tell Logstash that this is a metric beat application. I can just tell Logstash with this input configuration that it is some application that's going to send me data in the Beats format. Now the cool thing about this too is that the Beats format is well documented. There are libraries you can use to send data from your application to Logstash over this protocol. So they come with a bunch of Beats applications out of the box, but you can write your own. You can embed this library in your application to send your data to Logstash. All right, in our next video, we are going to continue to look at the different Beats applications. Here we're going to talk about what they do and what the data that comes out of them looks like in Elasticsearch. We'll get back to using Kibana. We'll get back to looking at Logstash to see how the data looks like, and we'll visualize it all in Kibana that's pulling from Elasticsearch.